Right. So in this problem, we're obviously doing something inside the absolute value and after the absolute value. So it's going to have two effects. And I'll make the table of values. If I plug in -2 here, then I have -2 plus 1 is -1. -1 minus 2, -3. Okay, plug in -1. -1 plus 1 is 0. 0 minus 2. Okay, plug in 0. 0 plus 1 is 1. Absolute value is 1. 1 minus 2, -1. Plug in 1. 1 plus 1 is 2. Absolute value is 2. 2 minus 2 is 0. And the last one, plug in a 2, we get 2 plus 1, 3. Absolute value is 3. 3 minus 2 is 1. So let's graph those 5 points. Right? It'd be -2, -3, -1, -2, 0, -1, 1, 0. I got something wrong here, don't I? And 2, 1. Yeah, I know I got something wrong here. Let's try this again. -2 plus 1. That should have been 1 minus 2 is -1 here. That was a mistake. So you're supposed to catch that. See, that should have been, when I plug in -2, it would have been -2 plus 1, -1. Absolute value is 1. 1 minus 2 is -1. So that point should have been here. Okay, and then these points were okay. Because if I didn't have that, I wasn't going to see the V. Can we see the V? Right? Okay. So what's the shift that we saw go on? It started here, it went left 1, and down 2. Essentially, those directions are telling you the directions to the vertex, right? That's going to be the point of the V. And when you have a shift that involves both a horizontal and a vertical shift, at least in the book, at least in the homework for some of the problems tonight, they're using this word, diagonal. It's a diagonal shift because it went both directions. I don't think that that's universal, but that is something you'll see. You okay with that? So again, if you have an H and K going on, so it's both horizontal and vertical shifts, that's diagonal shift.